Okay everyone, welcome back. We're in section 5.4 now, which is on something called the multiplication principle, and we're continuing to count the number of elements in sets in this section. So I'm going to use some notes that I've made previously to avoid or to kind of speed things up here. Let's see. So first question. Suppose I have a red shirt and a green shirt and a blue shirt. I also have a pair of jeans and a pair of corduroys. Question is, how many different outfits could I wear to school? This problem doesn't require any sort of complicated math formulas. We can just list out the different possibilities. I could wear jeans with the three different colored shirts. I could wear corduroys with the three different colored shirts. That gives me a total of 6 possible combinations. Now this is a simple example of a more complicated math principle called the multiplication principle, or the multiplication rule. So it goes something like this. If there are m1 ways to perform the first task and m2 ways to perform the second task, then we're going to multiply m1 times m2 ways to do both tasks, one after another. This can be generalized, and we can add in M3 and M4. So in general, if I can figure out the number of ways there are to do each task individually, then I can figure out the number of ways there are to do the entire group of tasks one after another by multiplying. So in this last example, we listed out the different possible combinations. We got 6, but we could have done this using the multiplication principle by saying, well, there are 3 ways to choose a shirt, there are 2 ways to choose pants, so altogether there would be 3 times 2, or 6 ways to choose a shirt followed by a pair of pants. Okay, once again, in general, if you have to figure out how many ways to do a bunch of tasks one after another, multiply the number of ways to do each task separately. Let's see some more complicated examples. So let's see, area codes. It used to be that area codes couldn't start with a 0 or a 1. The second number, though, had to be a 0 or a 1, and the third number could be anything. Our question is, how many area codes are possible given these conditions? So what I'm going to do is I'm going to break this problem up into 3 different tasks. The first task, I'm going to figure out how many ways there are for me to choose the first digit of the area code. Second task would be how many ways there are to choose the second digit of the area code, and then finally, how many ways are there to choose the third digit of the area code. And then I'm going to multiply those all together. So here's how it works out. Since the first digit can't be a 0 or a 1, that leaves 8 possible combinations. Any integer from 2 to 9. 2, 3, 4, 5, 6, 7, 8, or 9 gives me 8 possible choices right there. How many choices are there for the second digit? Well, the second digit has to be a 0 or a 1, so that leaves 2 choices there. Finally, the third digit could be any number from 0 to 9. That's 10 options. Altogether, 8 times 2 times 10 gives me 160 different area codes. 160 different possible combinations, possible ways to choose each digit under these conditions. Okay. Let's see, what about license plate? So let's say a state is looking at its license plate requirements. Currently, the state requires 3 letters followed by 4 numbers. How many different combinations are possible? So we are going to break this down into individual tasks. We have 7 positions to fill in the license plate. So first 3 have to be letters. How many letters are there? There's 26 letters in the alphabet, so we have 26 choices for each of the first 3 positions. The last 4 positions each have to be numbers. There are 10 choices for each of those 4 positions. Altogether, we have 26 multiplied 3 times, 26 to the 3rd power, and then 10 multiplied 4 times, 10 to the 4th power. Altogether, that's 175,760,000 different possible license combinations. Okay. What about this one? TV stations and radio stations east of the Mississippi River have call letters that have to begin with the letter W. How many 3 or 4 letter call signs are available? So this one has a little bit of a twist to it. We're going to have to figure out each of these separately and then figure out some way to combine them to answer the question here. So first, how many different 3-letter call signs are available? Well, if the first letter needs to be a W, then there's only one choice there. The second and third letter could be any letter of the alphabet, so there's 26 choices for both of those. Total of 676. What about 4-letter call signs? 4-letter call signs work a similar way. The first letter has to be a W, but then the remaining 3 could be any letters. That's a total of 17,576 4-letter call signs. Now, how do we combine those? Well, if we want to figure out how many 3 or 4-letter call signs are available, what do we do with these? We're going to add them together. A total of 676 plus 17,576 is 18,252 3 or 4-letter call signs. Now, why did we add this time where we've been multiplying before? This last step right here where we add goes back to the last section that we were looking at, section 5.3. Here we go. This formula. So remember, the union of two sets, the union consists of everything in one set or the other set. So if I want to count the number of elements that's in one or the other set, S or T, then I can figure that out by taking the number of elements in S, adding the number of elements in T, and subtracting the number of elements in both sets, the number of elements in S and T. This is that counting formula that we talked about in section 5.3. For this, and the key thing here is that the union represents that or word, or 3 or 4 letter, so call signs. So if I want to apply this for this problem, the number of 3 or 4-letter call signs can be found by taking the number of 3-letter call signs and adding the number of 4-letter call signs. Now for this problem, it's impossible for a single radio station to have both 3 and 4 letters. There are no radio stations that have a call sign that is both 3 letters and also 4 letters. It's impossible. So that last bit goes away. We call two sets, this is a little side note, but we call two sets whose intersection is empty mutually exclusive. So in this case, the 3-letter and the 4-letter sets of call signs would be two mutually exclusive sets, meaning that there's no element that has both 3 letters and also 4 letters. Just a little side note. But the big idea is whenever you're faced with an OR problem here, that refers back to this formula. We're going to add the number of elements together. Okay, so give those homework problems a shot. Please let me know if you have any questions, and I'll see you in the next video.